Good morning, students. This is Dr. S. Prabhakaran, Assistant Professor, Department of Networking and Communication. So today we are going to see some basic interview questions on some common concepts like array, constructor, polymorphism and all those things. So in this particular thing we are going to have two videos. One video we are going to see some basic interview questions on the array concepts, and in the second video we are going to see some basic interview questions on the C++ features. Now, without wasting much time, we will move into the question. As instructed in the earlier slide, so we are going to three different types of models of questions. Now, first we move into the first question. Now, the first question. So, in this particular thing, we are going to dive into the fascinating world of array. Especially, we will explore to find union as well as intersection of two sorted array. Now, before going into the code, I'll just give a quick review on what we are going to do. So literally from this thing, we understand that we have two sorted arrays, that is array 1 and array 2. We have to find the union as well as the intersection using efficient algorithm. But the key idea is to traverse both arrays simultaneously, leveraging the fact that they are sorted. Now we move into the code, then you will have a better understanding. Now on seeing to this code, basically we are going to decode our code into three different sections. That is, what are the functions that is used in the code as well as the main function. So primarily the functions what we are going to use in this code are find union and find intersection. So these are the two functions that we are going to use. So first we will decode that particular function. We will see what are the operation or the logic that is inside this particular function, and then we will move on to the entire flow of the code. Now coming to the first thing, find union function. So this function takes two array as input and returns their union. You can see it uses two pointers I and j, and it traverses array 1 and array 2 respectively. The main logic here it is given, this is important. See, if array 1 of I is less than array 2 of j, then we add array 1 of I to the union set and we increment it by I. And if array 1 of I is greater, so we add array 2 of j and increment j. Also, if they are equal, we add an instance, that is add one instance and increment both the pointers. So that's the logic here we have written for find union function. Now after the loop, we add this remaining element from both array to the union set. Okay, the similar sort of operation is done in the next function, which is called as the find intersection function. So here the same way like find union function, it also has two pointers which traverses array 1 and array 2. And if array 1 of I is less than array 2 of j, we move I, and if array 1 of I is greater, we move j. If they are equal, we add the elements to the intersection set and increment both the pointers. So that's the logic behind this particular function. Moving on to the next part, that is our main function. So we all know in the main function we have two sorted arrays, that is array 1 and array 2. So here we call find union as well as find intersection function, passing these array as the parameters, and finally we get the value printed from the union as well as the intersection using the cout function. So this is the overall logic about this code. Now we will quickly run through the code and see what is the output that we are getting. Now this is the same code that I explained. Okay, so find union function, find intersection function, these are the two defined functions as well as the main function. Now from this particular set of two set of arrays, array 1 and array 2, we are going to find union as well as the intersection. Now we run it to have a better understanding. I'm just increasing the visibility of it. Now see, just correlate the input with the output. Now clubbing these two array, that is array 1 and array 2. Okay, so the union among these two things are, we are going to add everything 1 2 3 4 5 6 7. So this is the union of array. And coming to intersection, that is the common element that is present in both array 1 and array 2. We have 3 and 5. So this is the output that we received after successful compilation of the program. So basic thing is, as expected, the union contains all the unique elements from both the arrays and the intersection contains all the common elements. So this is about the first program. So now we will move into the second program. Yes, so the second problem, here in this program we have a straightforward task, that is we are going to reverse an array and a string, but the twist is here that we are going to use stdlib function. That particular library function is std reverse function from the algorithm header. So we have a header file wherein which the definitions of stdlib of reverse function is already defined there. We are just going to call the reverse function from that particular header file. That is the new thing that we are going to learn from this particular program. Now in the same fashion, okay, we are going to decode the program one by one, okay, and then we will dive into the demo part of that. Okay, now looking at through the program, the same thing here. We have two functions, namely a reverse array function as well as reverse string function, because as instructed in the question we are going to reverse both array as well as the string here. Now first we are going to reverse the array, okay, and look, see the array here is a array function is a template function that takes an array and it's the size as the parameter, and inside if you see we use the stdlib, that is a reverse function which efficiently reverses the array. And secondly we use another function called reverse string function, which takes a string reference and directly applies to the standard reverse functions, and it reverses the string in a place. That's the important thing that we need to understand here. And then switching over to the main function. So in the main function we have an array as well as the string. So array is arr and string is str, and for the array we calculate its size using size of function and array of 0. So then we call the reverse array to reverse it, and for the string we do it directly. See, for the string we directly call the reverse string and to reverse it. Now see, if we run the program, how the code works. We'll see the magic of reversing in action by using stdlib reverse function. This is the beauty of this particular function, which elegantly reverses both the array as well as the string. So this is the thing. This is what I have given, std reverse function, which is defined here in include.algorithm. Okay, so for the easier understanding I have given commands in all the important functions, so you can understand the proper flow of the control. Okay, so now we run the program. So if you run the program, this is the answer that we get. Now you can correlate with the input as well as the output. Now coming to the input array, so this is the input that we are passing 1 2 3 4 5. So when we pass into the particular function of reverse function, it has to reverse it, and see the answer is it has reversed and it has printed. So 5 4 3 2 1. And for the array, for the string, see the input for the string is hello, and if we give input to this reverse function, it has to reverse and the reversed string is printed. So if we pass input as hello, it is printed as OLLEH. So this is the output, right? So now we move into the third problem. In the third problem, here we are going to explore a unique approach for finding a repeating elements in an array using a special marking technique. Okay, here our goal is to efficiently identify the repeating elements within an array. So one important thing in this particular code, what we are going to do is we are not going to use any of the traditional method. Instead we are going to use a clever marking technique or a logic which achieve this desired result. That's one of the important thing that we need to understand. Now you might ask, what is the marking technique, sir? So very simple. I'll explain what is the technique. Okay, now the next this is the code for finding the repeating elements in an array. Now what technique is that? First we are going to iterate through an array, and for each element we mark its corresponding index by adding the array size to the element itself. And if during this particular process, if we have encountered any element whose marked index is already greater than or equal to twice its array size, then we identified it as a repeating element. So that's the logic that we are going to use. By identifying this, we can easily implement. So this is the code that is done in a function called find repeating function. So this particular marking technique, whatever we have explained, that particular logic is done in this find repeating function. So these are the two prime important thing that is done inside this find repeating function, that is marking the index as visited by making the element at the index negative, and if the element is calculated, the index is already negative, so it is a repeating element. So these two concepts are, that is, these two logics are embedded inside this particular function. And now the next thing is main function. So we all know in the main function we have array, that is ARR, with some repeating elements. So we just pass some random input there, and we calculate the size of array using the size of function as well as array of 0, index 0, and we then call the repeating function. Okay, so passing the array as well as its size. Now we will take a look, if we execute this particular code, how the result is being displayed. Okay, so this is the program. So now we will execute this particular program. Now see, after running this program, we can identify the repeating elements are 3, 6, 1. You just compare with the input that is passed in the array. So in the array we have some elements which are repeating too. The elements that are repeating are 3, 6, 1. So based on this particular marking logic, our function understands it and it prints all the repeating elements. So this is the basic logic. And now before winding up, you need to understand the benefits of the marking technique. What is it? First, it doesn't require any extra space. The marking is done in place of its original array. And when it comes to the time complexity, it runs in the linear time. And it is highly efficient approach for finding the repeating elements. So overall, we have successfully utilized this special marking technique to find out the repeating elements in the array. So I hope you have had lot of inputs from this particular session. Thank you.